Hello, this is Ray PCB, your trusted PCB partner. We have already completed the basic tutorial for KSAD. Starting from this episode, we will begin a new series introducing the application scenarios and design tips for PCBs with different numbers of layers. So today we'll talk about the significance of designing single-sided PCBs. Speaking of single-sided boards, many newcomers nowadays may rarely encounter them anymore. Because the manufacturing cost of PCBs has decreased, most people now start with double-sided boards, so single-sided boards are relatively rare. Let's take a look. I've modified our previous LED driver circuit and redesigned it as a single-sided board. From the PCB, you can see that there is only the blue layer and no red layer, only the bottom layer is present. The components have also been changed. All the resistors have been replaced with through-hole resistors, and the chip has also been switched to a through-hole version. This is because it's difficult to cover SMD components with copper on a single-sided board, so generally through-hole components are more commonly used on single-sided boards. Let's take a look at the 3D view of the single-sided board. This is what a single-sided board looks like. As we can see, there is no copper on the top layer, only silkscreen, while all the traces are on the bottom layer, and the bottom layer also has copper pore. So this is a single-sided board. So why do we make single-sided boards? Even though the cost of double-sided boards is already very low nowadays, what is the point of using single-sided boards? First of all, single-sided boards can reduce the manufacturing cost of circuits because after all there's one less layer of copper and several fewer processing steps on the top side. Based on both the board fabrication fee and the unit area production cost, the manufacturing cost of a single-sided board is 2 to 3 times lower than that of a double-sided board. For companies, this can lower the cost of their products. From a practical application perspective, except for certain high-frequency circuits, surface mount component circuits, circuits that require a very small area, or circuits that are too complex, which are not suitable for single-sided boards, all other circuits can use single-sided boards. For example, for high-consumption electronic products like televisions, radios, audio receivers, and amplifiers, every effort is made to design the circuits as single-sided boards in order to reduce manufacturing costs. Actually, as you can see, it's mainly in the consumer sector, because of cost sensitivity, that there are still many applications using single-sided boards. For example, we can see that some switch mode power supplies and similar circuits use single-sided boards. In fact, even the materials are downgraded. While we currently use FR4 material, there are also some base materials similar to cardboard, which are even lower grade than FR4 to further reduce costs. Then, the second aspect is reducing circuit development costs. It usually takes multiple iterations to finalize a circuit, and each revision incurs another round of board fabrication costs. And it's not just about electrical connection errors in the circuit. Any structural adjustments to the circuit also require board fabrication for verification. Even for us, after designing many circuit boards, it's hard to guarantee that the design will be finalized in just one go. Especially when producing products in large quantities, you first need to verify the circuit's functionality. Once the functionality is verified, you'll work on reducing costs, optimizing for cost effectiveness, adapting to the enclosure, and so on. It often takes many rounds of version modifications before the design is finalized. So in general, it usually takes at least 2 rounds of board fabrication to finalize a circuit. Also, for circuits that use a large number of surface mount components, most of them require double-sided boards. However, making adjustments and testing surface mount circuits during the prototyping phase can be quite troublesome. So we usually start by using single-sided boards and standard components for testing. Not only does this reduce experimental costs, but circuits made with single-sided boards and standard components also have a high success rate when converting to surface mount components. This is mainly because the process is about miniaturization. Surface mount technology primarily involves shrinking the size of each component, which actually makes things easier. The overall size of the circuit can also be reduced. You just need to change the component packages and redraw the PCB. Although some high-frequency circuits are difficult to test with standard components, most control circuits can be verified using standard components and single-sided boards. Of course, this requires a high level of circuit drawing skills and speed, so during the testing phase, it's still more convenient to use through-hole components for modifications and testing. For example, replacing these resistors is much easier. Look at these chips. Before, we used to use sockets and the like, which made it very convenient to replace chips. The third point is shortening the development cycle of electronic products. When developing electronic products, making circuit boards is often a troublesome step. When you urgently need to finalize an electronic product, quickly producing the circuit board is key. Even if there is a professional PCB factory locally, they can't just drop everything and make your circuit board immediately. So usually making a board takes several days, but for single-sided boards there are many ways you can make them yourself by hand, such as thermal transfer, using an engraving machine, or just using a single-sided copper board. All of these are possible. So this is why it's so fast for prototyping. Once you've finished designing the circuit board, you can do thermal transfer and etching yourself, and it takes less than half a day to complete. Another aspect is that it lowers the entry cost for beginners learning electronics. Actually, as mentioned earlier, the production cost of single-sided boards is quite low, so the learning cost is also very low. Alright, that's all for today's introduction to the advantages of single-sided boards. If you enjoyed this video, please subscribe to my channel for more content. Thank you, everyone.